All right, welcome back. This is still section 6.5. This is video number 2. And we're going to talk about the quotient property of logarithms. Do you remember the quotient property of exponents? If we have b to the m over b to the n, we get b to the m minus n. And this is like if we had x to the 5th divided by x squared, that'd be x cubed left over. 5, 2 cancel, you get 3 left behind. Since logs are just exponents, there is a corresponding property for logarithms. Log base b of m over n is equal to log base b of m minus log base b of n. Let's practice using this formula. Here's the first one. We have log of x over 1,000. This is equal to log of x minus log of 1,000, which is equal to log of x minus 10 to the 3 equals 1,000, so this whole logarithm equals 3. All right, let's try one more together. Log base 5 of 125 over y is log base 5 of 125. Oh, I forgot my parentheses up here. Oops. Pretend you didn't see that. Log base 5 of 125 minus log base 5 of y. 5 cubed is 125, so that's 3 minus log base 5 of y. All right, why don't you try C, D, and E now? And be warned that E is another example of where you have to work right to left on a formula. All right, hopefully you were able to do these. If not, we're going to go over them right now. So this becomes non-C. This becomes the natural log of e to the 4th minus the natural log of 8. Well, what power do you raise e to get e to the 4th? And the answer is 4 minus natural log of 8. This is log base 2 on d of w minus 3 minus log base 2 of w plus 2. And the final one is where we work right to left. We have log base e, natural log. We have two different logarithms that are being subtracted, so we can write them as a single logarithm. Natural log of a plus f in the numerator over a minus f in the denominator. And that is the quotient property for logarithms. One more property here, and that is a power property for logarithms, just like the power property for exponents. If you had b to the m to the n, it became b to the m times n. This is like if we had x squared and then we cubed it, we got x to the 6th, right? This rule, I think it helps to make a little visual, and I like to see this p, and I think if I have log base b of m to the p, that p can come down in front to make p times log base b of m. Let's practice this with these examples on example 5. Log base b of x to the 7th, the 7 gets to come front, and that's log 7 log base b of x. Likewise, even if it's a negative 8, it gets to come out front, and that's negative 8 log of m. This one's a little bit trickier. Why don't you guys pause the video and give the next few a try? Again, E is going to be one of those examples where you work from right to left, and I'll make it a little smaller so we can see the rules at the same time. All right, how'd you do? Did you remember that square root of t is the same as t to the 1/2 power? T to the 1/2 power. The 1/2 comes in front, and that becomes 1/2 natural log of t. All right, this one is w plus 1 log base 3 of v, and you have to be careful with that parentheses in the w plus 1. That whole business comes down for the exponent, and you have to use parentheses. Otherwise, it would look like w plus 1 log 3 of v, and you really want the w times the log, not just the 1, so you can't do that. All right, you can put the exponent down in front. It means you can put it back up on top of the variable as well, so this can become the natural log of n to the negative 1/5. All right, let's put this all together. It says video 3, but I'm just going to keep going because we haven't been doing this video for very long. Still video 2. All right, let's put this all together to fully expand or some logarithms. That's the first thing we're going to do, and then we're going to fully contract them. All right, so let's fully expand log base b of x times y cubed. Well, the first thing I see there is a product. So I'm going to use the product rule to expand this as log base b of x plus log base b of y cubed, right? Almost expanded. I still have an exponent on the y that I want to bring down in front. So this becomes log base b of x plus 3 log base b of y. All right, why don't you guys try number 7 following a similar idea? Are you back from trying it? Did you pause the video? Let's give it a try together. The first grouping we have is a division problem, so we're going to use the quotient property. This becomes log base 5 of square root of t minus log base 5 of 25. Remember, the square root of t is the same as t to the 1/2. Minus log base 5 of 25. Using my power rule, the 1/2 comes out front. 1/2 log base 5 of t minus, well, what's power do you put on 5 to get to 25? And that's 2. So log base 5 of 25 is just equal to 2. All right, 2 more to try, I think. Yep, 2 more to try. Why don't you guys give these 2 a try, and then I'll come back. Just do 8 for now. Do 8, and we'll do that one together, and then we'll do 9. All right, did you give it a try? Let's do this together. The first thing I see is a quotient, so I'm going to go ahead and do the quotient first. This is the natural log of x cubed y minus the natural log of z squared w. And now within my quotients, I see some products. So this is the natural log of x cubed plus the natural log of y minus, and now you need to be really careful. I'm going to go ahead and put a parenthesis down. This is the natural log of z squared. Oops, I didn't want to write that like that. The natural log of z squared plus the natural log of w. But remember that minus sign applies to that all parts of that expansion. So we're subtracting the z squared, natural log of z squared, and we're also subtracting the w. And if you look, they were both in the denominator and should be subtracted in the final version. Let's do the power rule. We're almost done. 3 comes down. 3 natural log of x plus natural log of y minus 2 natural log of z. The 2 came down. And don't forget to distribute that negative out, minus natural log of w. Wow, I missed a lot of parentheses that time. One quick check that you can do is if anything is in the denominator from the original log, those should have negative coefficients. And if it's in the numerator, those will always have positive coefficients. It's really easy to miss that minus sign. All right, let's try number 9. All right, let's give this one a try. Log base 8 of 64 minus log base 8 of the square root of z plus 1. Remember, the square root is the same as power of 1/2. So log base 8 of 64 minus log base 8 of z plus 1 to the 1/2 power. 8 to the square is 64, so 8 to the 2 is 64, so that's just 2, minus 1/2 log base 8 of z plus 1. All right, that's it for this video. Go ahead and watch the next one, and that'll be the end of this section.